Distributed Plastics LLC would like to introduce you to a distributed optical plastic sorting method by simply reading the SPI resin code on consumer plastic waste. Distributed Plastics LLC is backed by Shen, a PhD candidate, and Joseph Boog, a master's degree student, both at the University of Utah's Electrical and Computer Engineering departments. Currently, consumer recycling is done in a big box manner, whereby large trucks go from house to house picking up recyclables. They then take these recyclables back to the plant where they have to sort them, compact them, and bale them for sale. Although this big box sorting method is proven day after day, these sorters are expensive because of advanced methods of discrimination. These sorters use visual and infrared wavelengths, spectroscopy methods where actual elemental makeup is determined, X-ray imaging for difficult materials, and lastly, the human element for anything that might have been missed. Although these big box sorters are marvelous feats of engineering, they come at a large monetary cost, both initially and through time. Now, in a recent case study done in Salt Lake Municipal's Recycling Center, they recently made a $7 million sorting capability upgrade. This upgrade is a great improvement for them. However, if recycling in general is done in a distributed manner instead, these types of costs can be greatly reduced. Now, before we get into the innovative technology, we need to review plastic resin. Remember that plastic is a synthetic material made from a wide range of organic polymers like polyethylene, PVC, and nylon. These polymers can be molded into virtually any shape and are easy to recycle if kept in the same resin family. This is why it is important. Keeping these polymers together allows for efficient recycling and more dollar per bale. Notice the code, the SPI resin code on this plastic bottle. Now, simply put, our innovative idea is a smart garbage can. This smart garbage can will take your plastic bottle, find and read the SPI code, and drop it into the appropriate internal compartment. It is centered around consumer plastic bottle waste and will automatically sort it as you walk away. It has 8 columnar sections, 1 for each SPI code and 1 as overflow, with a center hollow section that will contain smart electronics. Above this center columnar section is a domed top with an enclosure that holds the plastic bottle on an incline. When the bottle is dropped in, the algorithm reads the SPI code from the image, determines which bin to rotate towards, and opens a door and lets gravity take over to do the sorting. Notice here in the prototype overview, a high-resolution camera sends an image to MATLAB. The patentable detection algorithm then decodes the SPI code and sends that value out via serial data to a microcontroller. The microcontroller then drives a stepper motor and actuates a door to open, dropping the bottle and sorting. Actual prototype results show a noise-induced hand-drawn images sent to MATLAB. MATLAB detection algorithm successfully detecting the SPI code and sending that data via serial to a microcontroller. The microcontroller then correctly drives a stepper motor to the correct SPI code location, and a LED will blink showing or simulating that a door has opened. Now, our claim with this market potential is that Salt Lake County conservatively has a potential for a 30% increase in volume and a 3x decrease in cost if using a distributed plastic sorting method. The nitty-gritty of this claim follows. Salt Lake Municipal per week has a conservative capacity of 336,000 kilograms per week. Another conservative estimate of our distributed methods shows 431,000 kilograms per week. That is a third volume. Another conservative estimate over 30 years shows our distributed method costing $22 million, whereby the large big box sorters have a infrastructure, maintenance, and overhead cost of $70.5 million. Again, this reflects our claim as a 3x reduction in cost. Remember, at Distributed Plastics LLC, we thank you for your consideration.